Hi students, our study now is about probability. First of all, in probability we have what's called the universe. A universe where we're going to do our experiment, probability experiment. So for example, the cards, we have 52 cards. So this is the universe, which is called denoted by omega, are all the 52 cards in the card. These elements are called eventualities, each one of it, like A1, and any subset of it is called event. For example, suppose I said I want A is a set of hearts. So here it will be, you have 13 cards of hearts. So here you have more than one, you have 13 cards, and you have heart 1, heart 2, heart 3, till heart 13. So these are called events because it's a subset of the omega. And A intersecting B is formed of all elements common to A and B. Suppose A is the set of the hearts, which said it's 13, and B is the set of kings. We have, four kings. So what's the common between A and B? The common between A and B is the king of heart. Here you have king of heart KH, and here the kings, we have three another kings, and here we have the 12 other cards. So here A intersecting B will be the king of heart, this is the intersection, and the union will be everything, the A and the B and the intersection. It's either in A or in B. Now we have in math what's called A and A bar. A bar, we know it from before, it's everything outside A. Everything that does not exist in A. So that's why A plus A bar is everything. Suppose I said I want the elements of I want to pick a heart or not a heart. Not a heart, it means heart bar. So it will be everything. So that's why we say P of A bar plus P of A is everything, and P of the universe is 100% correct, is 1. So that's why we say always P of A bar is 1 minus P of A. Suppose picking a heart, we all know what the probability of picking a heart. You have a heart, suppose H here, P of H P of heart, picking of heart, I have 13 choices out of 52. Not picking a heart will be P of heart bar will be 1 minus P of H. So it will be the rest in 1 minus 13 over 52. It will be the rest of the cards, which is 39 over 52. Always probability is between 0 and 1. And P of all events, what's the probability of picking a card from the 52 cards? Any card, it can be the heart 1, heart 2, club 1, all of them will be what? 1. There is something, if A and B are two events such that we don't have common. Suppose you have here A and here you have, this is set A, and here this is set B, and you don't have anything in common. For example, here the set of hearts, here the set of a club. Do we have anything between club and heart? So we don't have. So we say here A intersecting B is phi, and this is called incompatible or mutually exclusive. What is incompatible or mutually exclusive? It means that we don't have any common in between the hearts. Let us take example. Suppose we have 3 red, 2 black, and 1 white in an urn, marbles or balls. Here you have it. Let A be the set of red 1, red 2, and white 1, and here red 3, black 1. These balls are enumerated, and C are 1, B 2. We can see that A and B, if you look at A and look at B, we don't have anything in common. So A intersecting B is phi. So here we say it's incompatible. However, if you look at A and C, we have R1 here, and here we have R1. Since we have intersection, so we say it is compatible. We need to draw from a deck of 52 cards 2 cards. Let A be the event of picking a king. So how many kings you have? We have 4 kings. 4 kings. And B be the event of picking a heart. So how many hearts we have? We have 13 hearts. And C be the event of picking a queen. So how many queen we have? 4 queen. Certainly between A and C it's incompatible. Why? Because we don't have common between king and queen. So we say A and C are incompatible. However, B and C, yes, we have common, which is the Queen of Hearts, so compatible. Between A and B, also we have the King of Hearts, so this is compatible. Given two sets. Now concerning, suppose if you look at this picture, if you want to say this is A, this is the set A, and this is the set B. If you want to add, for example, A union B, you're going to tell me A union B is consists of all elements in A and all elements in B. But you realize when you say it's all A, if you want to count all A, and then you're going to count all B, so you have the common, you have counted it twice. So that's why, to be accurate, you need to get rid of one intersection. Because in A you have intersection, you have this intersection, you have counted in A, and you have counted in B. And suppose you have set A and B, you have here 1, 3, and you have number 5 in common, here you have 7, 9. So if you want to say set A is 1, 3, 5, plus set B, it will be 5, 7, 9. But we realize that we have added 5 one time, so you must exclude one intersection, so minus set 5. So that's why we say P of A union B is P of A plus P of B minus P of A intersecting B. And if they are incompatible, so we don't have intersection, so we say P of A union B, like this picture, it will be PA plus P of B. So P of A union B, getting A or getting B, event A or B, is P of A plus P of B minus P of A intersecting B. I want to stress on something called the complement. We said P of A bar is 1 minus P of A. P of A union B, suppose you have A union B and you have put bar, you can write it in two forms. It's either you say it's 1 minus, like we did up, P of A union B. I want everything except outside A union B. Or P of A union A bar can be written, guys. You can do the complement of each one. So the complement of A will be A bar. The complement of union will be intersection. And the complement of B will be B bar. It's the same. Yani P of A bar. Yani suppose you have P of A bar union B. If you want to write it in one complement, you can say it's the same as P. You can put a bar for all. Here it's A, and opposite of union is intersection. And since opposite of B is B bar, so B bar for A is A bar, intersection union, bar and bar, it will be B. Okay, so that's why here you can write it P of A union A bar is 1 minus P of A intersection, 1 minus P of A union B. This is wrong. Or you can write it directly as P of A bar intersection with a B bar. Okay, so this is don't use the second one. Dependent and independent events. Now we're going to start by the probability. Suppose a draw are dependent. What does it mean dependent? If I want to draw the first card, I will not return it back. I will keep it by myself. I will keep it with me. And when we say dependent in counting, it means without replacement. Independent, it means for example, suppose you want to draw two cards with replacement. What is the probability of picking a queen in the second draw, knowing that the first one is a king, and draws are done with replacement? You're going to tell me it doesn't matter. So getting a queen the first or a king the first, it doesn't influence the second card, because I want to return back the card, then I want to draw another one. So this is called independent. So independent, it's called P list. This is the P list that we know in counting. However, if it's dependent, it's either arrangement or combination. So probability of that sort, it will be favorable number of cases over total number of cases. So here we say that the draw are done without replacement. So either we do it arrangement that we know over total arrangement, or we do it combination over total combination. And if it's the independent, there is no relation, which is a P list, the draws are done with replacement. We do P of the first, each draw alone, P of the first draw, then P of the second draw. But here we need to take a note that when we say P of A times P of B, I'm going to get A in the first draw, then I'm going to get B in the second draw. Here the draw are done with replacement. So by examples you will understand what I mean between dependent and independent events. So let us start examples. Number 1, consider an urn containing 2 red, 4 white, 3 black balls. We need to pick 3 balls. Find the probability of picking 2 red. I didn't say that I will return the balls. I want 2 red. So if you want to do 2 red, if you want to do the probability of 2 red, so we say P of 2 red. I want to pick 3 balls, and I want 2 red and 1 not red. In the red, 2 red. So these are called dependent, because the second row depend on the first, because I'm doing it without replacement. So if you want to do it before in counting, you used to say it's a combination because order is not important. I want 2 red, I have 2 red, so 2 out of 2, and 1 neither not a red, so it can be a white or a black, so it will be 1 out of 7. In probability, what do I add? Only I add the total. So how many draw I want to draw? I want to draw 3 out of the total number, which is 9. I have 6 plus 3, 9. I want 1 white, so it means I want white and 2 not white, because I'm drawing like we did before. So here in that case, how many white I have? I have 4, so it will be combination because order is not important. 1 out of 4, 2 not white, it can be red or black, I have 5. Over total is 3 out of 9. I want the first 2 are red. Here order is important, so it's arrangement. The first 2 are red. You want red, then not red, because here without replacement, it's dependent also. It will be arrangement. I want 2 red, 2 out of 2, and 1 not red. It can be a white or a black, so 1 out of 7 over total, which is, as you can see it here, 3 out of 9. Black followed by a white, then a red. So order is important. I want 1 black, I have 1 out of 3. I want 1 white, I have 1 out of 4 here. I want 1 red, 1 out of 2 over total, which is 3 out of 9. So here in this example in A, B, C, D, these are called dependent because I'm drawing the thing without the replacement. So that's why either you do it combination over total if order not important, like in part A and part B, and if order is important, like in part C and D, we do it arrangement over total arrangement. Let us go to the thing when we have independent, like here. Suppose draws are done by replacing the ball before we draw the second. So this is independent. So in independent, we do P of each draw alone. P of the first times P of the second, but be careful, here order is important. So I want 2 red followed in part A. I want 2 red, here I'm doing part A, 2 red followed by a white. I'm drawing 3. So I want red, then white. So here if I want to draw, because with replacement, if I want to find the probability, I cannot do it like, for example, arrangement over total. So it's a P list, so I do each one alone. P red times P red times P white. So 1 white, 1 red. So how many red I have? I have 2. So I say 1 out of 2 over 1 out of 9 over total. And again 1 out of 2 over 1 out of 9. And P of white, I have 4 white, 1 out of 4 combination over 1 out of 9. And it's the same as writing it 2 choices over 9 without combination times 2 choices out of 9 because I have 2 red, and then 4 choices out of 9. So that's why we did it here like of that form. However, here if without replacement, either combination over total, if order important, arrangement over total. Then I want red, white, then black. So I want red. So in this order, by replacing the ball before we draw the second one. So P red times P red times P white. So it's 1 out of 2, 1 out of 9, 1 out of 2, 1 out of 9. As you can see here. And then white, I have 4 white, 1 out of 4, 1 out of 9. I want 2 red and a white. Guys, here by replacement, I didn't say the first two are red then white. So here I need to put all possibilities. I need 2 red and white. So either you have red, red, then white, or white, then red, red, or red, white, red. Because if you say only red, red, white, it means I want red the first, then red the second, then the third one will be white. I want 2 red and white, so I need to put all possibilities. The difference between dependent and independent. Independent, if order is important, directly I go to arrangement. If order not important, combination. In independent, I don't have this choice. It's always order important. If I say PA, then PB. So that's why if I want 2 red and 1 white, so I do all the possibilities. You can get red, red, white, or white, red, red, or red, white, red. So how many choices you have? I have 3 possibilities, so 3 times. P of red, you all know red. I have 2 reds, so 1 out of 2 over 1 out of 9. And then I want another red, 1 out of 2, 1 out of 9. And you want then one white, 1 out of 4, 1 out of 9. Instead of doing it plus 3 times, so I do it times 3. I want 2 red and 1 black. Sorry, here I want 1 red, one black, sorry, 1 red, 1 black. It means directly the other one will be white. Either you have 3 red, black, white, or red, white, black, or black, red, white, or black, white, red, or white, red, black, or white, black, red. So, but each one is equal to the other. So how many choices you have? 1, 2, 3, 4, 5, 6. Into red, 1 out of 2, 1 out of 9. Black, 1 out of 4, 1 out of 9. And white, 1 out of 3, 1 out of 9, and you get the answer. So there is a big difference between with replacement and without replacement. If with replacement, we do each one alone, but order is important. And if not with replacement, yani dependent, you do either, if order important, arrangement over total arrangement, or combination over total combination if order is not important. Another example, a deck of 52 cards. In a deck of, we need to draw 5 cards. Okay, find the probability of getting 2 jack. Here I didn't say I want to return back the card. I want 2 jack. So how many jack I have? Order important? No. So if you want to do it as combination before, you're going to tell me it's 2 out of 4, and you want the 3 not jack. And the 3 not jack is 3 out of 48 over total. I want to pick 5 out of 52. I want 3 honors. So 3 out of 16 and 2 cards not honors, 2 out of 36, like we did in combination, over 5 out of 52. Maximum 2 kings. Either you may have 0 king and 5 not kings, or 1 king, 4 not kings, or 2 kings, 3 not kings over total. So as we did before, but I'm adding probability over total. I want jack, queen, ace of heart, jack, and 1 king. So to be 5, because here I did a mistake. So 1 king, not 2 king. Okay. So I want, because I want order important, I have 2 jack. So here I have 2 out of 4. I want 1 queen, 1 out of 4. You can see it here. I want ace of heart is 1 out of 1. I want 1 king is 1 out of 4. Here 1 out of 4, guys. Over 5 out of 52. So here it's something wrong in the answer. But here the order is important. Suppose the draws are done with replacement. So with replacement, so it's independent. We need to do each one alone. I want 2 hearts followed by 3 clubs. So P of heart times P of heart, then P of club, P of club, P of club. P of heart, you all know it's 1 out of 13 over 1 out of 52. Or directly it's 13 over 52. How many 13 over 52? You have it twice. And similarly for a club, it's also 13 over 52. 13 over 52 3 times. So it will be power 5. Suppose I want to pick 4 hearts and 1 not heart in any order. Suppose I want it in any order. Suppose I said the first 4 are hearts. The first 4 are hearts in this order, and then not heart. So here we say P of hard times P of hard times P of hard times P of hard times P of not hard. So it will be 13 over 52 power 5, because all are equal to the same. But however, if I say I want 4 hearts, I didn't say the order, you're going to tell me I can have it this 4, or I can have it hard, 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 not hard, hard. Or I can have the not hard here, or not hard here, or not here in the first. So how many position I have? I have 5 position for not having a hard. Okay? So here in that case, don't forget, sorry, I did a mistake here. If I want in this one, let me repeat here. I want hard, 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 hard. I have 13 out of 52. For example, power here, power 4. And not hard, it is not 13 over 52. It will be 39. It can be clubbed 39 over 52 power 1. Okay? Because I have 39. So here I have, there is all wrong here. So it will be 5. I want 4 hearts. How many hearts I have? 13 over 52 power 4, and 1 without heart. It will be 39 over 52 power 1. Here I meant, I think, honors. Getting 4 honors, so that's it. I did the mistake. It's not hard, it's honors. So if I want, and I took H here, when I look here, I didn't look at number 2. I took it as hard. So if you want to take it as honor, I want 4 honors. So I want 4 honors. Any 4 honors you may have, and I want honor 4, P of H times P of H times P of H times P of H times P of H, and the last one not honors. But here, because I didn't say I want it in this order, so you can have the H bar here, you may have it here, you may have it here, you may have it here. So that's why times 5. And honors, you know that you have 16, 1 out of 16 over 1 out of 52. So it's 16 over 52. How many times? I want it 4 times. Power 4. It's like a P list where you have power. And you have 1 not honors, 36 over 52. But if you want to do it in this order, it will be directly, we don't do it times 5. So it will be PH times PH times PH times PH times P of H bar. In a class of 25 students, 17 like basketball. So let me do a Venn diagram. You have basketball, you have football. Suppose this is small a, this is small b, this is small c, and 5 they don't like any sport. They told us total is yani a plus b plus c plus the 5 is 25. Basketball, it means a plus b. They told us it's 17. Football is b plus c. Is 10. So if a plus b is 17, so c will be what? This is 17. 17 plus 5, 22. So remain c is a 3. Okay? And if b plus c is 10, so a will be, if b plus c is 10, 10 plus 5, 15. Right? B plus c 10, 10 plus 5, 15. So a will be 10. If a is 10, b will be 7. Okay? So find the probability he likes either. He likes both sports. Both sport, it means he wants P of B union F. Directly, it's 10 plus 7 plus 3. So it's a 20 over 25, which is 4 over 5. Find the probability he likes both sports. So the common, it will be 7 over 25. You can do it directly like I did it in Venn diagram. Find the probability that he likes only basketball. I want to get rid of the 7. Only basketball, it's 10 over 25. Find the probability he likes only football. You know, he likes only football, it is 3 over 25. But if you want to write it in probability, he likes only basketball, you say basket, and he doesn't like football. Basket without football. You know, basket, he likes only basket without football. You know, in other words, you're doing the union, everything, and from the union you're getting rid of the football. Probability of the football. Okay? Or you can do it directly. Suppose I said find the probability that, suppose you have set, for instance, you have set C for you to understand, you have B. Suppose I told you probability he likes only C. Since we have common only C, you say C and not B. C and not B, and you get rid of the intersection. So you're taking this part only. If you want B only, you say B and not C. Or if you want to write it, you can say it's P of the whole C minus the intersection. Here you say it's the whole B minus, you get rid of the common between B and C. Okay? Number 4, a die is rolled twice. Find the probability of getting 1 5. Since the draw in when you flip, when you roll a die, they are independent because the second row is not affected by the first row. So find the probability of getting 1 5. And you need to get a 5 and then not 5, or you may get 5 bar. We said independent in order is important, then 5. Probability of getting a 5, you all know, in 5 and then not 5, or 5 bar and then not 5. To get a 5, you know you have one choices out of 6. Not 5, you can get 1, 2, 3, 4, then or 6. So it's 5 out of 6. I have it twice instead of writing it again, so times 2. Both are 5, so 5 and 5. So P of 5 times P, both are 5. Sorry, both are 5 here. Not 5. Both are 5. So P of 5 times P of 5. So 1 over 6 times 1 over 6 is 1 over 36. The second row is 5. And here the first one is not 5, then 5. So in the first one you have 5 over 6. And then 1 over 6 to get a 5. So it's 5 over 36, as you can see. We flip a coin 4 times. So come in, flipping a coin independent, because independent, the second row, the second flip does not depend in the first one. Getting heart, heart, T, heart in this order because it's independent. So P of heart times P of heart times P of T times P of H. Each one is half, either a head or tail. So half times half times half times half, 1 over 16. I want a 3 head. Either you have, I didn't say the order, head, 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 then tail, or head, head, tail, then head, or head, tail, head, head, or tail, head, head, head. Each one is 1 over 16 because half times half. So how many choices you have? You have 4. So 4 times 1 over 16 is 1 over 4. Given P of A is 0.3, P of B 0.5, determine the intersection. If A and B are incompatible. We know if A and B are incompatible, intersection is 0. Okay? Here I meant not incompatible, are independent. So if independent is, if it's incompatible, it means 0. So you get 0. Here I meant independent, but I wrote it by mistake incompatible. Independent, so P of A intersecting B is PA times PB, because we said it's independent. So it will be 0.5 times 0.3 is 0.15. Find P of AB intersecting if A union B is 0.4. We know that P of A union B is PA plus PB minus P of A intersecting B. So in that case, it will be P of A union B, which is 0.4, equal PA is 0.3 plus PB is 0.5 minus P of the intersection, so it will be 0.4. Suppose A is inside B, what will be the intersection? A intersecting B is A, so it will be 0.3 directly. So I'm going to stop here the first video. In the second, the probability consists of 3 videos. The first part is about ordinary probability, where dependent or independent event. The second one is conditional probability, and the third part will be total probability. Thank you for listening.